Bismillahirrahmanirrahim. Hello and welcome to the 15th video of this series. Today we will going to explore what are fundamentals of asynchronous programming, what is async, what is this keyword used for, what is await, what are futures and what are streams. As well as I think before moving forward with today's lecture or with today's topic, I just want to get a recap of our last video, what we did in our previous video. So we have covered concurrency, what is parallelism, how to write code in threads, what are threads, what's the major use of threads, why do we use shared state concurrency. So we have covered that concurrency and parallelism means running tasks in parallel, but the major difference was that we have learned in previous video that parallelism means that independent task runs or the task runs in parallel independently, and concurrency means the tasks run in parallel. But we haven't covered that what the major difference. Some of you might think that both of these concepts are similar because the tasks are running in parallel, but no, there are some differences that we will cover in today's video. So let's, before moving forward with today's video, as usual, I in previous videos I have shared some of the great resources with you that I found on internet. So same as previous videos, today I will not be sharing any resource or any blog article. Instead, I will share you uh, code block. I will write a code and we will differentiate or we will compare different block of code that will at the end resolve the same problem. Let's say, let's just think of squaring input number that user will give us through arguments or through CLI. So what we will do, we will continuously ask an input from user, and let's say user have given us input 5, and we will in return print the square of that number, let's say 25, and then we will repeatedly ask user. So how what are different approaches to accomplish this problem or accomplish this task? So we can go for, let's say, simple task. Let's say we can apply the continuous loop and then implement the std, I'll write the code after that explanation. So another approach would be to use iterators, because we I have shared you a website or article about the iterators. There were multiple methods, you can say the other methods like filter map, and there are multiple other methods that I had shown you uh, uh, the resource last time. So let's just get started with today's video. So let's say, what's the problem statement that what we want to do? We want to get the input from user, and return the or, or print the square of the input. So there are multiple approaches that we can go for. Uh, I would suggest you can write the code on your own, and let's just compare with my approach, and we can discuss about that in comment box, or you can DM me. So let's say, let's take the user input first. Let's say user input, and you can go for stdn. Let's say, or IO. Let's just import IO and std, and we can go for, let's say, read line. All right, what this read line does, it will store okay, one more thing, string new. Let's just do this, or we can also go for, and then let's just pass this user input to that, and then we can go for expect, uh, let's say, fail to read input. It's fine. Let's just do one thing. Save it and let's just print what we have inside this user input. Print ln, and let's just directly print the user input. And what we have here, so expected mutable reference mutable. So I have to add the mute keyword here to mutate. Yes, let's just save it. And then what we have here, expected mutable reference mute string found reference string. So mute to make it mutable. All right, perfect. Let's just run clear cargo run, and then what we have it here. It's taking a bit of time. All right, sorry, I forgot to add the input. So let's just import it, and we have 5 here. This is the input, and this is the output. And before, right, let's just add an input. Let's say enter a number to a square. All right. And let's just do one thing. Let's just convert this string into a number. So let's say number equals to user input dot uh, dot parse. This will be converted to U32 type, and then let's just do expect expect fail to parse the string, and let's just directly convert this number or just print this square number multiplied by number, and the square of the this will be user input is equals to, and then let's just do this, save it, and let's just run the command cargo run, and enter a number. Let's say add 5. Here we have parse int error invalid digit. So what does this mean? Fail to parse the string. So it has failed to parse the string. So what would be the better solution to work with that? So because we have we have to trim the line, because right here you can see a blank line. It's getting the blank line, so we have to remove all the spaces, all the blank spaces from the string, and let's just convert this cargo run, and then it will convert this 5. The square of the 5 is equals to 25. Square of the number 5 is equals to, and then let's do number, and let's say if I enter the number, what happened in format string. Okay, now what if I want to uh, take run this infinitely until user all right, let's say cargo run, and what we have it here, enter a number to square, let's say 25. Square of the number 25 is equals to 625. If 5 25 10, it will be 100, and it's continuously running. So I have pressed the control C to break this loop. Okay, so what should be, or what are the other approaches to do this or accomplish this task? So we can follow, or we can use dot lines method that we have explored or learned in the from the iterators website. So let's say, let's quickly do one thing. So std in, okay, let's just import directly std in dot, and we can do lines. So lines, what this lines is, let me show you. consume this handle returns an iterator over input lines. It will return an iterator. So ये ऑटोमेटिकली आइट्रेट ओवर करता जाएगा लाइंस पर. सो वी डोंट हैव टू मैनुअली एड दिस लूप. So we got rid of this loop, and instead we are using the iterator. So let's say std lines, and now what this std lines will do, let's say what we have it here. So we can use any of the methods. So let's just do one thing. Let's just map over the iterator. So let's say x is a closure, and x is returning result, which the first argument or the first enum or the first value or of the enum is okay, and the other one is error. So let's just do one thing. X dot, we have multiple others. So what we have to return from this map, we have to return the okay value, the actual value of the. So let's just return the okay. Now save it. Uh, okay. Now let's just map over that specific value. So let's say map, and what we have in this map, we have an option of string. What we have it here, we have an option of string. What we can do, one more thing, let's just add filter map. And now what filter map does, it's doing the same thing, but what we have to do, so let's say x dot and then there is a method and then. So what and then do, if the value, if there is some value, then it will perform the task. Either way it will be excluded from, it will not run this function. So let's say अगर, let me just explain this in Urdu or Hindi. यहाँ पर वो iterate over करेगा input lines पे, and then it will map over, वो map over करेगा. और because this closure is returning result enum, the first will argument or the first value would be string, and the second would be, the other one would be error. Same as here. What we got in here, we got the string value, and we had to parse the string into number, the U32, the type has mentioned here. So let's say, let me just press Alt Z to break the line, or let's just do one thing. Let me press Alt Z and add the line break manually. Okay, so now यहाँ पर we can provide the closure right here as well. So let's say uh, x, instead of x here, let's just pass y to differentiate between them. Y dot then, and then let's say z. Now what we will do, we will parse the string, because right here you can see we have a string in that z, this closure, from this closure. So let's say z dot trim, yes, and then parse the same thing we did here, same thing we did here, and let's just do one thing, u32, and then let's just pass the, and we have, let's say it might get failed because it will return, let me show you what this will return. This will return a result. All right, so what we can do, we can add another block of and then. So let's say and then let's say a, and what this a will have, let me save it, or let's just move to the next line, save, and let's just directly return a dot, um or let's say what we can do here, dot, okay, and we have u32 here. So let's say what we can do, we can, let's just do one thing, um, print ln, enter a number to square, or let's just do this thing, and let's say what we will do, let's say let's just square it and print the output. So let's say let square is equals to a or let's just do one thing, value. Let's do this well, so it will be easy to understand what this a is. So val multiply by val, or you can add the exponent, and then let's just print the same thing. Let's say make this square instead of this, and then let's just use, instead of user input we will, and instead of returning anything we will do sum. We will return an option sum. At the end we can do, let's say, collect. And instead of doing this, because we are not uh, returning anything, so we can add this empty parenthesis right here. Let's save it, and what we have hit here. All right, it's working fine, but it is throwing an warning that unused return value of collect that must be used if you really need to exhaust the iterator. Consider for each drop instead, or you can also use this. So let's just without doing anything, let's just run the run the program. I go run, and this is the warning. Let's just print 5. All right, here you can see. Let's just move this. Let's just save it for now, and then let's rerun this cargo run. What we have, let's just input 5. The square of the number 5 is equals to 25. Let's 10, 100. One more thing, how we can optimize this, or how we can update, what are the other methods that we can go for? We can remove this filter map to add the for each loop, because from filter map we are getting option string. However, if I let me remove the filter map. Now here you can see the program is working fine. Here you can see there is no error here, but we are getting an error here. What is a value of type empty parenthesis, let's say, because we are returning an option sum. So what it's saying, cannot be built from an iterator over elements of type option. It cannot be returned like that. The trade of from iterator option is not implemented for empty parenthesis, but trade from iterator is implemented for it, required by a bond introduced by the method call chain, and required by a bond in collect. So instead of doing this, because we are implementing iterator and returning the option, so let's just do for each loop. Let's just run for each loop. For each loop give us the support of adding a closure. So because let's say if don't want to use the closure value, I can add the underline or underscore. So let's say I'll just return an empty parenthesis, or what we can do, we can return some as well. So let's just try with this. Okay, it's working. Let's say cargo run. Now here 5, 25, 3, 9, 2, 4, 8, 64, and so on forth. So here you can see this is the pretty much easy one. We can use this one. This approach is fine as well, but because we are on lecture 15, and on book, let's say we are on chapter 17, so what we have to do, we have to try different other ways to optimize our code, write the optimized code, and we should try different other approaches to make or get hands-on or get fluent into the Rust programming. So I hope this is pretty much easy for you. You have uh, got to know about different uh, other concepts of the Rust programming and the iterators. So how or why we can use filter map, what's the usage of, or why we can use, or why we have to use and then dot and then. uh, because previously we have used dot expect method or dot unwrap method. So instead we haven't used dot expect method to return or throw an error. So what this program will do, it will iterate over the inputs, map over that. If there is an okay value, if there is no any error, it will go to this map. In here, why, if there, and then means if there is any value, then go into this block, else go next for go move forward. If there is any value, and then means if there is any value, then go into this block, else move out. So let's say run the command cargo run, and let's just add the string. It won't be able to parse because I have passed the string instead of a number. So it's asking me for the input repeatedly. You can see if I am entering 5, now it has returned me number. So how much, or I guess you have understood how this code is working, and what's the major difference between both of these code, and how much robust is this code and this one as well. So yeah, so let's just move forward with today's lecture. What are async fundamentals of asynchronous programming, async, await, futures, and streams. So many operations, all right, let's just highlight it. Many operations we ask computer to do can take a while to finish. It would be nice if we could do something else. And so let's just, instead of reading all this theory, let's just go back into the code and let's just understand, if you are coming from the JavaScript world, so how we used to write asynchronous program and what's the difference between that. So let's say, in if you are coming from JavaScript world, so how JavaScript code runs, it runs by default synchronously. So what does synchronous means? Runs, running by line by line. So let's say एक code मैंने लिख दिया, let's say let a is equals to 5, then console.log, let's say 5, sorry, a, and then let's say मैंने लिखा b is equals to 1, and then console.log b. So synchronously means the line number 39 will run first, then line number 40, then it will run synchronously line by line. We will see the value of a in the output. Let's just run this code. Let's just go to the Chrome browser, or let's just go to the uh, let's just Mozilla console. I guess it's visible. Yes, let's just zoom in. Let's just paste this code. All right, let's just do one thing. Let I haven't copied this. Let's just copy this and paste it here. Paste it. Okay, are there any restrictions? Canvas state saved. Okay, take care when pasting. All right. So let's say, let's just quickly open this view inspect you. Let's just go zoom at console. Let's just you don't disallow stackers. So all right. So let's just get a Chrome window here. All right, here you can see I have just pasted this code, and you can see we have 5 at first place and then 1 on the second one. console A 5 and console B 1. And let's just move to the VS Code. All right. So now what asynchronous means? Asynchronous means to uh, remove this behavior and run the code in asynchronously. What does asynchronous means? To not to wait. Let's say if I have uh, added this the keyword is async here, it does not make sense. But let's just I have written this async here, and let's say, all right, let's just write the code. Let's say const let's say a, or let's say num function num func is equals to, let's say, asynchronous. Now this async keyword indicates that this function will run asynchronously. What does asynchronous means? Now let's just get here. So let's say I'm calling an API. Let's say const response is equals to, let's say, await, and let's just fetch, and let's just add any URL. Let's say we have JSON placeholder. Let's just get the JSON placeholders API. JSON placeholder. So let's just get this really quick. Free fake REST API. So so let's just quickly go back. So let's say I have added a URL here, any of the URL. So now what does this means? The code, the JavaScript or any of the language will get to know that this function will run asynchronously, and then in this specific block, this line will be run. This line will run, but here is another keyword await. What does this means? That the specific language will wait for the response from this line. So let's say मैंने एक API call किया, I have called an API, and until the I will get any response from the API, it will wait for the response. However, there is another twist. It will not wait here. The program will run. Let's say I have called this function. Let's say inside main function, and I have called this num func, and later after I have, let's say, a is equals to 1, and let's just do one thing. Let's just quickly get this. So what does this mean? This code, the language will not wait here. This will not wait here. The program will continue its execution. However, inside this function, it will wait. Let's say the language is running here. It has called this line, and in the meantime, the language got the result from there. So it will stop execution here and go back or move back to this implementation. Let's say यहाँ पे उसको response आ गया, तो वो यहीं पे ही अपनी execution रोक देगा. It will not move forward to line 52. It will go back to the function where I have implemented the await, and it will get the response, and then the program will run as expected. Let's say the next line will run as, let's say, return response. Let's just do response.data, whatever. So it will return the data, and then the program will run or execute same as it was working. Let's say after this line, console.log a b, and then console log b. So this was pretty much it if you are coming from JavaScript background. But however, it's by default JavaScript is works synchronously. So there is another support from Node.js. It's event loop. So what this event loop, because JavaScript is a single threaded language. So um, what the single threaded means, that it has to wait for the response, and as soon as it will run that. And we can get deep dive into this thing later on. And what we what's the difference between single threaded and what is event loops. You can explore this later on. So let's just quickly go back to the Rust documentation where it is. Yes, here. So let's say we are here. So parallelism and concurrency. Once we start writing programs that involve parallel or concurrent operations, though, we quickly encounter new challenges inherent to asynchronous programming, where operations may not finish sequentially in the order they were started. This chapter builds on. So they are telling about what we will cover in this chapter. So in both examples, the operating system's invisible interrupts provide a form of concurrency. That concurrency happens only at the level of the entire program. Though, let me just quickly go to the actual. So you are exporting video. All right. So let's consider an example. So you are exporting a video you have created of a family celebration, an operation that could take anywhere from minutes to hours. The video export will use as much CPU and GPU power as it can. And if you had only one CPU core and your operating system didn't pause that export until it completed, that is, if it executed the export synchronously, you couldn't do anything else on your computer while that task was running. So let's just take an example. Parallelism means the tasks are running in parallel and it will end up, let's say, at the same time. So the task will run simultaneously. And on the other side, concurrency, that means the tasks will run in parallel, but it's not necessary that they will run simultaneously. Let's say there might be some interrupts. There might be, let's say, delay in any of the specific function or any of the specific thread, and let's say one thread ends up first, and the second one ends up, let's say, a bit late, 10 seconds late, and whatnot. Uh, so what this means, concurrent tasks means the threads or program will run concurrently, the in parallel, but there is not necessary that they will end up at the same time. They will run simultaneously. There might be interrupt calls in between. There might be some other delays in between. So, but however, parallelism means the tasks will run simultaneously and then ends up at the same time. So let's say we could avoid blocking our main thread by spawning a dedicated thread to download each file, and they are creating different scenarios so you can explore that. So we have the example here. We have treated parallelism and concurrency as most inchargeable so far. Now we need to distinguish between them more precisely because the differences will show up as we start working. So when an individual works on several different tasks before any of them is complete, this is concurrency. What does this mean? When an individual works on several different tasks before any of them is complete, this is concurrency. Maybe you have two different projects checked out on your computer, and when you get bored or stuck on one project, you switch to the other. You are just one person, so you can't make progress on both tasks at the same time, but you can multitask, making progress on one at a time by switching between them. So let's take an example. Let's say we have an escalator here. um, let's take this here, escalator. All right. On escalator, let's just understand what this switching means. So let's say uh, RAM, or let's say we have a task creation here. And then let's say it is RAM. The tasks are, let's say, scheduled here, and then it is sent to, let's say, CPU. Let's say there might be some delay. Let's say कि भाई one P1 process P1 it's scheduled for, let's say, running. It is scheduled and move forward. It is moved to CPU, let's say here. Let's say P1 task scheduled हुआ, and then it has been scheduled. Let's say, let's just consider an example. It's kind of a scenario of an exam. So P1 is scheduled inside, let's say, RAM, and then after that, as soon as it got it its turn, it is moved to P1 is moved here. However, P1 wants a specific resource, let's say uh, R1, which hasn't been scheduled yet. So what it will do, instead of waiting here, it will be moved to here. So it will be rescheduled as soon as this task is available inside this time. So let's say क्या होगा कि अब ये जो task switch हुआ means now it the RAM will reschedule any other task P2, it will be here and then moved here. The P1 will be removed and moved to here, and then let's say P2 here. So this is switching, context switching kind of thing. Okay, let's say P1 अवेलेबल, यानी P1 को किसी चीज की जरूरत थी, किसी रिसोर्स की जरूरत थी, वो अवेलेबल नहीं था, तो वो वापस रैम में आ जाएगा, यानी स्केजुलर में आ जाएगा. And then as soon as that specific resource is available, the context, there will be context switching. So let's say if P2 was scheduled, so there are multiple algorithms for that. Let's say FIFO, LIFO, first in, first out, LIFO, last in, first out, and so on and so forth. So we can get to that part later on. It's the specific to the OS thing. So let's say a concurrent workflow A1, B1, A2, B2. What does this mean? This is task A and this is task B. When the team splits up a group of tasks by having each member take one task and work on it alone, this is parallelism. So the task or the task are working or the independently. So you can see this is working independently on that. This is B1 is working independently on its, let's say, task, and so on and so forth. So this is the pretty much example of this thing. Let's just quickly remove that, and let's just quickly go to the next topic, 17.1, futures and the async syntax. So um, what are futures? We have understood about, or we have learned what is async, what is the use of keyword await, what this indicates, what it tells to the programming language, uh, what to do. So let's say the key elements of asynchronous programming in Rust. Let's just quickly get the highlighter. Programming in Rust are futures and Rust async and await keywords. Future, what does this mean? Keyword, future is a trait, and in this trade, we have, let's say, output, and the second one will be poll. So I'll tell you what are these. Future is a value that may not be ready now, but will become ready at some point in the future. If you are from JavaScript background, so you know that there is something called promises. What this promise means, let me just quickly go to where is this? Yes, window. Yes, here. So let's say there was, let's say, promise. You can see new promise. Oh, I haven't added the solver, resolve and reject. So let's say there are two different arguments, reject, and inside that, let's just keep it empty right now. ABC. And inside that promise, we have a promise and it's pending. The state is pending. And as soon as this promise is resolved, let's just quickly do one thing. Add set, let's just add set timeout. Set timeout. Let's say after 5 seconds, get it resolved. So let's say resolve it after, let's say, once ABC. Wait 1 second. Let's just, instead of doing this, that A equals to, let's say, this thing. Identify A has been declared. So let's do uh, promise, and let's say right here you can see promise fulfilled. As soon as the promise is full resolved, it will fulfill. So same as here, inside the future we have two states. uh, where is this same concept shows up in many languages, sometimes under other names such as task or promise. Rust provides a future trace as a building block so that different async operations can be implemented with different data structures but with a common interface. In Rust, futures are types that implemented the future trade. Each future holds its own information about the progress that has been made and what ready means. As soon as full in JavaScript we have fulfilled, in Rust we have ready. This is a state. You can apply the async keyword to blocks and functions to specify that they can be interrupted and resumed. So this is pretty much it. So they are creating their first program. So let's just do one thing. Let's just quickly go to the VS Code, comment all this stuff. All right, everything is done. All right. To use the asynchronous, or to make our program asynchronous, we have to install different crates. So instead of installing different multiple crates like Tokyo or Serde JSON for serialization, so instead what we are doing right now, we can install cargo, add, and TRPL. What does this mean? The Rust programming language. So Rust programming language has compiled or combined all the grades and created a single grade. So let's just run this command cargo at TRPL, and all right. So let's just quickly come here, and we can start by writing a function. Let's say function mhm, get uh, placeholder data, and where we have to write the async keyword right here, async function, and then let's just we will not return anything right now. Let's just do one thing. Let's just quickly uh, create an API. What we have an API call, where go to the where it is, Mozilla Firefox here, yes, and the placeholder API. Let's just get this API, yeah, right here, to do's, and inside to do's what we have. Okay, so let's just get response is equals to response. What I'm doing, response, and from TRPL, let's just uh, get the, and we have to pass the URL. So what was the URL? I have copied that, and let's just add the await. As soon as I will write dot await, this means that the Rust program will await or will wait for the response from this URL. So let's just quickly convert this. Let's say let um, what we have in to do's. What we have it tried, and inside that we have congrats, you have made, okay, okay, 100 posts. Let's just get posts, and inside that post, instead of getting 100 posts, we can post, I guess, post. All right, why it's a bit of slow, slash post. All right, so let's just quickly go, and what we have, what will be the data inside this post. So let's just quickly open in a new tab, or let's just quickly open this in um, Chrome. It's taking too long. Okay, perfect. So we have JSON placeholder dot typecode.com slash post, and inside that, from this post we have, okay, we have user ID is an integer, means U32 unsigned integer, ID, title, and body. Let's just only get the IDs. So Let's just create a struct, let's say post, and inside that post we have ID will be u32, and let's just quickly post post will be of type post vector post, and let's say response dot, and we have text. What this text do, and dot text, and we will do uh, where is spec, or let's just quickly do add away, and let's print this out. Post, save it, and let's just run this function here. So to run this function, instead of directly calling this function, we have run. And inside that function run, we have this function has been renamed to block on. Please see its documentation. We will look on into it. So what this function remains to maintain compatibility with the online versions of the book that use the name run. So inside the book we have run, and they have renamed it, so we can rename, or let's just go with this. So it accepts the future. Let's just pass this function, and let's what is throwing an error. Expected struct vector post found struct string. Okay, so there is another thing that we are. Let's just quickly what we have it. Okay, we are getting response as an string. So let's just quickly run this command, and we will use the serialization Serde. Let's just install run command cargo run, and let's just okay, it's taking too long. What happened? All right, we have both as a string. You can see these are 100 posts. So let me see how we can get the uh, what should be, how to limit that post. Might be there should be any, if they have implemented something to do's one, so they have to do's one. Okay, so might be they have implemented the REST API protocols. So let's just implement the limit underscore limit. Let's say limit is equals to 5. Might be they have implemented this. Let's just rerun the command cargo run, waiting for the file, and then it's running, fetching the data. Struct pose is never constructed. Why it's taking so long? All right, so it's okay. The data is here. So we have user ID, title, and the body. So instead of getting this response as a string, we can convert, let's say, consider this as body, and let's just create post, and post vec post, and let's just install the, let's clear this out. Let's just install two other traits like cargo add Serde and cargo add Serde JSON. Let's just quickly add this. Okay, perfect. Now, w- first we have to implement the deserialized trait. So what does this mean? Let me drive macro, and then let's say deserialize and debug as well. Debug and deserialize. Let's just import this from Serde. You can see here I have imported deserialize from Serde. Now another thing, from stir we have another method from Serde JSON. So now what it will do, it will take body, means the string slice, and then it will return the result enum. So instead we can add, let's say, failed to parse string or JSON, whatever you want to do. And let's just print these posts. Now let's say clear cargo run and in this, okay, and let's just wait and field in this struct IDU32. All right, okay, perfect. So we have the vector of posts and we have id2. So where are the other fields? So we haven't included all the fields that. So what it does, it will exclude the fields that we haven't included in this struct. So let's say if I want to add, let's, what was the other fields? Post slash post and add limit of 1, or we can do slash post slash 1 as well. So let's say user ID, title, and body. So we have user ID, title, let's say title would be string, and body. And if I rerun this program, cargo run, so let's just quickly fetch these. Post has a drive implemented for the state debug, but this is intentionally ignored during that code. All right, let's just. Okay, so it's warning that convert the identifier to snake case. So for now, let's just use this user ID. So yes, here you can see ID 1, user ID 1, title, and blah blah. So this is how you will fetch. Let's say I will print ln here, let's say hello, as well as hello one, hello. Let's say, oh, what happened? Print ln, oh, my bad. Save it and let's just rerun the command. I haven't added semicolon. Okay, okay, so I have forgot that. Waiting for the file log. Let's just quickly go back to the documentation until the program runs. Let's just move this here. Okay, let's just close everything here and let's just start with. Okay, so they are it's starting with the creation of their first program. So all right, so what they are doing, they have created a function page title, and they are calling TRPL colon, yeah, get function. They have passed the URL dot await dot text dot await, and they are parsing the HTML. So HTML parse, and they have passed the string dot select first, means they are fetching the title. So let's replicate this code and let's quickly go remove everything, and let's just copy that specific part of the code where it is. All right, copy this and let's just go back here. Okay, we have hello one, and we have, let's say, the a function call, and then we have hello two. Let's just quickly comment all this stuff. Comment all these things. All right, let's just create another function to fetch the page title. So All right. So we are importing future as a trade. Let's just explore what are different stuff in the future trade. So inside the future trade, we have type output, and another thing we have here, this poll. What does this poll do? So this poll will go every time and check whether there is any response, whether the state has been changed or not. So once a future has completed, returned ready from poll, calling its poll method again may panic, block forever, or cause other kinds of problems. The future trait explains no requirements on the effects of such a call. However, as the poll method is not marked unsafe, thus unusual rules apply. So let me show you what are. An implementation of poll should strive to return quickly and should not block. Where is it? The poll function, explanation of poll function, where it is. All right. This function returns poll pending and poll ready. And inside that ready, we will have a value. Attempts to resolve. This function returns both of these values. Once a future has finished, client should not poll it again. So let's say if future has been finished, so you cannot call the poll function again. When a future is not ready yet, poll returns call pending and stores a clone of the waker copied from the current context. This waker is then woken once the future can make progress. So let's say it will again woke up when, let's say, जब वो progress करना शुरू हो जाएगा future. For example, a future waiting for a socket to become readable. Okay, there is another word concept, socket. So let's just quickly take an example of chat application. So you are getting replies real time. So let's say on WhatsApp, on any of the chat medium, you can you are sending hi to someone, you are getting a message, let's say replies directly instead of. So we have implemented sockets so you can get the real time data. Let's just understand this for now. We are not getting deep dive into the sockets part right now. To become readable, would call dot clone on the waker and store it. When a signal arrives elsewhere indicating that the socket is readable, waker wake is called and the socket futures task is awoken. Once a task has been woken up, it should attempt to poll the future again, and which may or may not produce a final value. All right, that's clear. And the TRPL HTML, it hypertext markup language. It has a field inner, and inside that inner we have scraper HTML. What does scraper HTML will do? It has a struct. The HTML is a struct. In this struct, we have errors field, quirks mode, and tree. So let's, if you are from JavaScript or you know about web development, so uh, in a web page you have a tree of nodes kind of thing, or you can say we have DOM, document object model. So inside DOM we have multiple, there are trees of nodes, and if I can show you in this inspector, and inside that inspector, if you can, let's say, so you can see here we have doc type HTML. This is a tag for whole the HTML. This is HTML tag, and inside that HTML tag we have head tag and the body, and inside that body we have. So it's creating a tree of tags kind of. Let's say tree of nodes or tree of tags. Let's consider for the easy example or to remember it easily. So let's say HTML. Inside that HTML we have two. Let's just bring the skeleton here. Let's bring it here. All right. So let's just close this. Okay. So we have HTML. Inside that HTML, we have, let's say, head and body. Eight body. And inside head and body, we have inside head we have, let's say, multiple tags, title, meta tags as well, and other. Body has, let's say, div tag, span, p, h1, and so on and so forth. So this is kind of hierarchy or tree of nodes. So let's just get back to the code. So here you can see we have this kind of stuff. Let's just close everything and get back to the implementation. So async move means they are implementing the move. We have already explored this uh, keyword and what it does. This code block will do. So go to the page title. Let's just okay, wait. Let's just implement the same thing instead of passing my own URL. Where it is. Okay, perfect. Let's just get copy this thing here. Instead of getting URL from arguments, let's just pass HTTPS, let's say Hadi hyphen header.netlify.app. Okay, so page title URL, await some title, the page title for save it, and let's just quickly run the command cargo run what happened. Okay, so everything is working fine. Ta-ta-ta-dun. Okay, the title for this website was home Hadi header. And if I want to run it on loop, I can do that. Or let's say I can add match statement here. Let's say uh, let's get any other. Let's get this URL here, save it, and get the title of that specific Rust documentation. Okay, we have the title was futures and the async syntax, the Rust programming language. Is it? Yes, it is. You can see I have hovered over this icon and you can see futures and the async syntax and so on so forth. All right. So let's just go to the next topic. Okay, before moving to the next, we have either. So what either will do, it will um, so let's just explain. Let me explain this code. In, so TRPL run the program, run this asynchronous block, and inside that we have TRPL race. What does this mean? And TRPL race has two things: title, future one. It will get titles of both the websites. Let's say I have passed the URL, my URL of my website, and let's say I have passed URL of my other website. Let's say I have two websites. So it will get the response from both the websites, the title of both the website, and it will wait for them. And it will return the data or the title of either of them. Either means it will the TRPL race means either let's say left will bring in the response first or the right will. The let's just quickly remove this. Come here, copy this. Um, let's just quickly comment that block. And okay, I have. Let's just move this to top so that and okay, so let's just move this and I'll explain you what that means. So let me pass, let's see, TPS that on netlify tab, and then let's say the other one would be HTTPS, let's say, okay, HTTPS, let's say, Hadi header 055.github.io. All right, let's just save this and let's run the command cargo run. So I have added the URL of my both the websites, and let's see which websites bring in, or from which website I will get the title first. And its page title, and I got the response, or the response is from https hadiheather05.github.io, and it has returned the response first. Its page title is Hadi Heather and software engineer. The title is this. So how it is working, it's comparing. So it's this kind of, you can, let me go back, go explore this function. Inside that function, we have futures for both the arguments f1 for function 1, future 2. And inside that, it is calling the select function. In that select function, we have select the future, and either left, it will return either left or right. And what does this mean? It will wait for any, it will wait until it will get the response from any of them, either from this one, either from this one. So this is the simple thing, and this is printing match statement and so on and so forth. So this is pretty much it from this thing. Let's just quickly go to the next topic, 17.2, applying concurrency with async. So now we are uh, applying the concepts we have learned in the chapter 16 about concurrency. So what it is doing, creating a new task with the spawn task. Let's quickly, in this section, we will apply async to some of the same concurrency challenges we tackled with threads in chapter 16, because we already talked about a lot of the key ideas there. In this section, we will focus on, in many cases, the APIs for working with concurrency using async are very similar to those for using threads. In other cases, they end up being quite different. Even when the APIs look similar between threads and async, they often have different behavior. So how to create a new task with this spawn task? So we have to run this TRPL. It, this is must to run beforehand, to run this asynchronous or futures block. So we are spawning tasks through the Rust programming language grade. This is a spawn task, and then we are spawning task asynchronously. So async, and this, what it is doing, it is sleeping for, let's say, 500 milliseconds. So let me run this block here. You can see, um, ta-ta-da, playground communication timeout. All right, so let's just copy here. Let's just comment this stuff. Let's just run the command. So what this saying, so we have an output here, high number one from the second task, high number one from the first task. Here, high number one from the second task, high number one from the first task. What does this mean? It's running, is spawning it. TRPL run, we are seeing that it has spawned in task one, and here we are running this loop. So it will run asynchronously. As soon as we get the response, it will run this. Let's say first time it will run high number one, let's say starting with one from the first task. It has printed this line, and it went on sleep. So this, as we are getting the sleep, and now it will go move forward with this one. So it has run this, and this code block got go went on sleep. So it went again to the top. We have response, and then so on and so forth. So it is working. Let's say number one from the second task, number one from first task, number two from first task, number two from second task, and so on and so forth. And if they are doing handle dot await dot unwrap, so they have stored this code block into a variable, and then they are adding the dot await dot unwrap method, and that's it. Okay, so now we have another method dot colon join, where we can pass two different futures and wait for it. We will get the same response as we used to. So this is pretty much it from this chapter because okay, there is one more thing. So what they are doing, they are sending the response. So what they are implementing? They are implementing the channel. We have already learned about MPSC, message passing, multiple producer, single consumer thing. So here we have implemented TRPL channel. I have already told you we have combined all the stuff, and TX mute RX TRPL channel. Inside the TRPL channels, we have TRPL sleep. All right, tx.send, we are sending the value. What this value would be? First will be high from the future. It will receive the values line by line. And that's pretty much it. So if you want, you can implement that on your side as well. So let's just move to the 17.3. Working with any number of futures. You can work with any number of futures you can implement. Let's say they have implemented txt1 rx future, txt future. So they have implemented multiple futures and they have stored it into a vector, and then they have implemented a join all using a join all function, futures and dot await. Here the expected async block, same thing that we have already learned, that uh, the ownership will goes out of scope, so we have to implement smart pointers. So we can implement different smart pointers. Let's say they have implemented the box new, and then there are errors like required by a bound. Let's just quickly explore what we have inside the join all. Let's close this. All right, my bad. Why I have implemented main function side main std time duration. Let's just quickly remove, comment this out. TRPL and colon join. And inside that join, let's just go to the implementation pub function join all. What this will get? This will get the iterator join all. It will return the join all. What this join all is, join all struct. We have kind join all kind. We are going to the enum join all kind where we have a small, big, and inside that we have a small inside a small we have lms which has pin is here. You can see pin has pointer, and then uh, they have bootstrap only, public for bootstrap, and then the private for. So this is the complex implementation that we can, if you want to learn the Rust programming language in depth, so you have to explore the implementations of different grades or different functions that has been used into your program. So let's say they are implementing these different. So let's say if you want to raise a function, we have already seen that specific stuff right here. Where is this? Okay, we haven't implemented right here, but we have seen if we want to raise. So what we can do, we can, let's say TRPL raise, and inside that raise we have to pass two futures. We have already explored this, the implementation of raise. So inside that future, inside this raise function, we have to pass two futures. It will raise, and it will return the response from any of the code block. Either way, if we are getting the response first from future one or the other ones, the left or right. So they have passed slow, fast. Slow is they have implemented 100 milliseconds of sleep, and they have implemented the 50 milliseconds of sleep, and they are running this. So yielding control at the runtime, and so forth. All right, this is pretty much it. This is the simple implementations. All right, so one more thing, what I'm seeing right now, building our own async abstractions. So they are implementing their own async implementation. So here they are showing you the timeout function, which is accepting the future. What timeout will do, that let's say, mm, there might be sometimes, let's say the API or the website URL is wrong. So it should, instead of, let's say, getting or fetching the response, let's say there might be an example we can consider. कि एक website है, there is a website which responds us in, let's say, 10 seconds. They have, let's say, thousands of the data they are sending in response. So what we have to do, we want to get the response from any of the API in 1 second, and we have to show them to the user or the on the front end, let's say. So what we can do, we have to add the timeout. So let's say if we get the response from that specific API or website until this timeout, let's say 1,000 milliseconds. So if if this future is, or this function is running in below this timer, it's fine. We have to fetch the response until this time, or we have hit this limit. We have to time out, or we have to exit. We don't want to fetch the response from that. We will exit that block, and we will move forward with the execution of the website flow, backend, whatever. So what they are implementing, TRPL run, they have implemented the slow and timeout function. So they are passing the future and duration, how much, for how much duration they have to continue with the future. So let's say await and then println succeeded, or error after the duration. So duration failed after dash much seconds, duration as seconds, after 2 seconds. So now they have implemented this timeout function, TRPL raise, and inside that raise they are passing, or let's say TRPL sleep for how much time. So instead of passing a separate future function into that right one, they are passing TRPL sleep, and for how much time, this much seconds. So this is pretty much simple implementation, failed after 2 seconds. We got the output, let's say. Streams futures in sequence. Now, you have heard of streams of data. What does this mean? Streams, you can consider it as sequential data, sequence of data coming from any of the, let's say, website, or if you have implemented sockets, so you are getting. Okay, one more example you can go for. If you have seen chat gpt, so whenever you get the response from chat gpt, or you ask something, let's say pass any prompt, and chat gpt respond you, not, it will not directly uh, show you the exact response directly. Instead, it will show you word by word. So you will see, let's say, let's say my name is ChatGPT. I was built by this person, and so on. So this is how you will see the response. So there will be a streams of data coming from the sockets or backend, you can say. So far in this chapter, we have mostly stuck to individual features. The one big exception was the async channel we used. Recall how we used the receiver for our async channel earlier in this chapter. So you know how we have consumed the receiver and the consumer from the TRPL channel. The async receive method produces a sequence of items over time. This is an instance of a much more general pattern known as a stream. We saw a sequence of items back in chapter 13 when we looked at the iterator trait in the, they have mentioned the chapter, but there were two differences between iterators and the async channel receiver. The first difference is time. Iterators are synchronous while the channel receiver is asynchronous. The second is the API. When working directly with iterator, we call it synchronous next method. With the triple receiver stream is in particular, we call an asynchronous receive method instead. Otherwise, these APIs feel very similar, and that similarity isn't a coincidence. A stream is like an asynchronous form of iteration, whereas the triple receiver specifically waits to receive message, though the general purpose stream API is much broader. It provides the next item the way iterator does, but asynchronously, and so on and so forth. So what they are doing right here, so they have implemented the stream by getting the iteration values. So values dot iter, they are iterating over the values, the vector, and then mapping over it to multiply the number and multiply by 2. Here you can see no method found next. Here they are using stream dot next dot await, and they are getting that no next method is applied. And now let's just quickly go to the implementation and implement this stuff. Close this. Let's just do replicate this. And inside that we have to import the uh, stream from iter. Okay, let's just save it. Cargo run stream. Okay, now we have to import stream from stream exit, from where we are input. Okay, use TRPL stream exit. Let's just save it. And what we have, do we have an error? No, it's perfectly fine. Let's just quickly run the command cargo run. Here you can see the data value was 6, 10, 12, 18 multiplied by. Okay, if value is they have they did the modulus of by 3 if it is equals to 0, or modulo of 5 if it is equals to 0, they are filtering out, and then they are printing out the filtered. So filtered dot next, filtered will be filter, and inside that filter there will be iterator of map range. So this is perfectly fine. Let's just go back to the implementation. So now they are implementing the channel, the same examples, the same implementations that we followed into our previous subchapters. So this is pretty much it from this thing. A closer look at the traits for async. So we have already looked into the traits, how these what are the implementations into that traits. So inside the futures, how this pin works. So let's consider pin builds on that to give us the exact guarantee we need. When we pin a value by wrapping a pointer to that value in pin, it can no longer move. Thus if you have pin box sum type, you actually pin the sum type value, not the box pointer. You are pinning the this value, not the box. This is the smart pointer. You are not pinning this value. So in fact, box pointer can still move around freely. Remember, we care about making sure the data ultimately being referenced stays in place if a pointer moves around, but the data it points to is the in the same place. And then unpin, and then we have, let's say, so they are explaining what unpin and pin does, the stream trade, what we have inside the stream trade. Let's just go and explore the stream, what we have in the stream trade. Stream, and inside that stream, we go to stream, and inside that stream, we have type item, values yielded, well, means the value got from the stream. And what we have, the poll next. Same thing as we have inside the future poll poll method. So let's say define an alias for item, and inside this poll we have poll next. There are several possible return values, each indicating a distinct stream state. Poll pending, poll ready but some value, poll ready but there is none. Might be if poll is ready, so the ready will have the option enum. So it will return you some value or either with the none. So this is pretty much simple thing. So this is thing, and the last futures, tasks, and threads. So they are combining everything inside a single function. and they are explaining you how this works. Uh, let's say, let's, okay. So let's just quickly go and explore. Okay, so inside that, for this implementation, let's say एक process आया उसके वो scheduler, so context switching. So there are multiple algorithms for that. If you want to explore or deep dive into the operating system or how the tasks and process schedules the tasks and how context switching works, what is the major difference between parallelism and concurrency, you can explore this in deep. I'll try to bring some examples for you. I have it here. So let's say Mutex is. All right. So before, let me bring it my LinkedIn post. So let's just quickly go and get the LinkedIn. All right. So if you haven't followed me on LinkedIn or on my socials like Twitter X, so you can do so. So let's say I usually try to post some theory about what I have explained in that specific video, and I usually share some uh, relevant context about the stuff. So let's say I have shared concurrency versus parallelism, same thing or different. I was trying to explain to viewers or users that because this is the common concept between amongst user or developers that concurrency and parallelism are same concept, but no, you have already learned about that, so you know better. So just posted a new this is pretty much it. Parallelism: multiple tasks running simultaneously, think multiple cores working at once. So you have explored this with example like multiple users working on different tasks to achieve a single goal or so. Concurrency is equals to managing multiple tasks that may not run at the same time, dealing with interruption and coordination. We have already learned about that. In backend systems, when you handle concurrent API requests, you are managing multiple requests, even they are processed one after another. But when your server uses multiple threads to handle these requests simultaneously, that's parallelism. And there is another thing, making sure these concurrent parallel operations don't crash into each other. That's where Rust ownership shines. So we can use mutex like a smart. We have learned about locks, mutexes. So we can implement that to avoid crashing of, let's say, any of the thread. So someone asked me about how do you ensure a mutex doesn't become the throughput bottleneck under load. So there is difference between latency and throughput. So latency means, let's say, time delay or delay in, let's say, let me show you an example through Excalibur. So latency, and let's say there is another thing, throughput. Throughput. Like, so latency means कि आपका backend how much time it takes to get the response, or time delay, time latency. Let's say if a backend server is let's say responding to 5 requests in 2 seconds, so its timeless latency is good. If you reduce time and increase the API response capability, or so backend is much faster. So this is relevant to the time delay time thing. And in throughput means how much requests that a backend server can accommodate in a respective or in a specific time. So they mean, so how to ensure a mutex doesn't become the throughput bottleneck under load? So if there are multiple requests, there is, let's say, thousands of requests at a time. So how this mutex cannot become the bottleneck? So I found out different resources that I have shared with him. So let's say, thanks for the question. This is definitely a concern for production system. From what I have learned so far, we can minimize this issue by using multiple mutexes instead of single lock. So let's say instead of using a big or a single lock which is consumed by all the other threads, instead we can create multiple smaller locks, which we can say lock stripping and arc. We have already learned about that atomic reference counting pointer can help with shared ownership patterns, but you are right that locking isn't always the best solution. However, it really depends on the specific use case and access patterns. And I found out these resources. You can also follow me, or you can go through each of these examples. So there is another mutexes are far faster than spin locks. So you can also learn about what are spin locks. So you can get deep dive into the Rust programming and different. You can explore different functions, different concepts. What's you can compare with your native programming language that you are working on right now. So, because you are learning Rust right now, but if you have any experience with any of the language like JavaScript, Python, Go, any of the language, so you can compare the concept with your language, let's say on which you are currently working on, and with Rust. So, what are the differences between? So, usually I compare the concepts with JavaScript. So, if there is any concept in JavaScript, if the concept exists in JavaScript, I used to compare it with that. If there isn't any concept in JavaScript, so I try to find different scenarios, that how we can create scenarios and how we can understand this better. Let's say कि भाई कौन सा concept अच्छा है, सॉरी कौन सा concept किस तरह हम यूज कर सकते हैं हमारी implementation में, how can we use that specific concept or that specific method into our hands-on application in real world example. Because from now on, from the next lecture, we have OOP, object oriented programming, how we can do OOP in Rust. So you know about what are different abstraction methods in OOP. You can, let's say, overriding, overloading. There are multiple other concepts in OOP. You will also get to know about that, patterns and matching, advanced features of Rust, let's say unsafe Rust, advanced traits. There are a lot of things into that. And side by side, I will try to create web applications or backend servers, starting with small applications so you can or we can get hands on it, and then we will move on to the bigger or large scale applications, and later on we will move on to the building or web3, the implementations of smart contract and so on and so forth. We will learn about ink. This is another technology. We will also go to Polkadot. We will explore substrate as well as XCM, and there are a lot of stuff that we can learn later on. So this is pretty much it from today's lecture. We have learned about asynchronous programming, streams. We got deep dive into the trades and everything. So if you have any questions about that, you can reach out to me through on my socials. You can drop your queries in comment box. If you have learned anything from this lecture, so you can let me know if you have learned anything from this lecture, and if you have any questions about any of the concept that isn't clear for you, so you can let me know as well. And you can like this video, subscribe, and you can share with your fellows. And if you have any feedback about the video, about anything, so you can uh, drop your feedback into the comment box. I would love to hear that, and I'll try to make this video, these lecture series more useful for you guys. So till the next video, stay safe, stay productive. Till the next lecture. Bye.